Yesterday, I did conclude on this topic, on this the second last topic, which was the gravity location technique, on how we can locate. We can choose the location of an industry or location of a plant using the gravity location problem solution. And yesterday, I already passed through all of this. I started here and I explained, I said, for us to get we need to get the plots, because these plots, yesterday I did say that this could be the different locations. These are the different locations of the available markets. These are the plots of different locations with their names, which are in our table, and we need to choose where exactly to put our plan. Our target is to locate our plan where it is more nearer to customers and where the cost of operation will be cheaper. So for us to get that, we start with the formulas here up, and we say we shall first calculate the x-axis of that location that we want. Then we shall also need to determine the y-axis of that location that we intend to have. So for the formulas for both, the formula is the same. It's the summation of the number of x times the load of x. This is the coordinate of x times the load which we are suspect to be supplying on x, divided by the summation of all the loads. The same goes to the y. And these are our locations, and these are the loads which we expect to supply, or the contracts which we expect to supply. And these are for the different locations, their load and their x coordinate and y coordinate, x coordinate, y coordinate for each location. And we said we shall begin with the first one. Of course, these are how our coordinates are plotted. This is how our coordinates are plotted. Our coordinates for these locations are plotted in our map like this. If you follow that, you will see that these are the plottings. Then secondly, we need now to determine where we shall locate our farm. For us to locate our farm, of course, the first formula is here. We say we take the x-axis, we want to calculate the coordinate of x. We take a number of the x-axis times the load of the x-axis, which is 90, then plus, because we need the summation, plus the number of the x-axis for the second location times the load of the second location, which is mountain area. Like that, we follow that order, and we shall arrange our work like that. Then this is for the y-axis, also the same. The number of the y-axis times the load of that axis, which is 90, and the number is 10.5, and we follow that order. Then here are our final arrangements. This is our arrangement for the x-axis, and this is our arrangement for the y-axis, after arranging it from the table with the way I was explaining yesterday and now. Then we shall be able to get our coordinate for the x-axis and our coordinate for the y-axis. Then from there, we pick our coordinates. For x-axis, it is 11.18, and for y-axis, it's 6.99. So that means we come to our y-axis and we look for 6.99, which is around here. And yesterday I said it could be around here. Then for the x-axis, it's 11.18, which we assume to be around here. And this is where the star is. On our plotting, this is where the star is. And we assume this is where we decide to locate our plan, so that we are able to minimize cost. We are able to minimize cost and be able to supply our customers. Finally, I want to go to the last module that we can use to calculate our location. These formulas are not for forecasting. These are for location. We are determining where to locate our farm. The other first ones were under location, but these ones are under the formula. These ones are under forecasting. We need to know how to. Sorry, the first ones are under forecasting. Then these formulas are to determine locations. In our summary, I'll put it up. So from this, we have what we call single facility location. The single facility location, for it, it is mostly aimed to determine the units we can supply at a quickest cost possible, the number of units we can supply when we are located, maybe for example, let me say maybe we are located on point B and our market is on point A at this point. So from here, I hope my cursor is moving freely and we are seeing it. Yes, okay, my cursor is there, yes. So we need to know what is the distance between point A and point B, because we need to know where we can put the number of units we can supply at this distance when we are to move at a straight line. So we need to calculate that. This is more connected to the first formula whereby we use coordinates, but with this one, in other words, we are determining the units we can supply at the lowest cost possible at a straight line, so that we know where exactly to plot or where exactly to locate our farm or our plant. So this is just a demonstration. Of course, we shall have our X plot for the B. We have our X number and we have our Y coordinate. X for B, we have a Y coordinate and X coordinate. For A, we have the X coordinate and the Y coordinate where there is the dot. So how do we come up with that? This is a very simple formula. In this, we use what we call the rectilinear formula for us to determine the distance of this on the straight line, so that we know how many units can we supply when we are to travel on a straight line and we don't move on the straight line at the shortest distance possible, because we need to know what distance can we have, which is the shortest and which can help us to determine between the farm and also the market. So we need to know how many units are we able to supply within there. How do we calculate this? It's the easiest. The formula is we take the x-axis, we multiply the first x-axis minus the second x-axis minus the first x-axis. As we see here, we have the first x-axis and also the second x-axis is down. Then we have the first y-axis and we have the second y-axis down. Of course, I said this plot is this x and this y, the way we plotted the first one. This one, I don't need to, you look at it at your free time. So we assume that in our distance or in the coordinates of the different locations between B and A are this. There is 1 and 2, and 1 and 2, as we looked at here, we shall take the first, for the coordinate of x, we shall take the second x-axis minus the first x-axis. So this 4 is the second x-axis, and this is our first x-axis, because this is xy. This is x1, this is y1. This is this is y2. This is this is x2, this is y2. This is x1, this is y2. This is x2, this is y2, sorry. So we pick those plots depending on our formula here. So we pick our second x, which is the 4, for the x coordinate. We minus it with our first x, like this, x1 minus the x2 minus x1. So the x2 is 4 and x1 is 1, which is here. And we get our answer as 3. Then we come to our y coordinate. Also, we pick the second y, which is this, minus the first y-axis, which is this, and we get 4. And then we add the totals and we get 7. So this becomes the number of units that we are able to supply in between the two locations. That is our plant and also our market. So from there, we shall be able to know how many units we are able to supply within a straight line distance between different locations. So with this, we have reached the end of this lecture. And I think this was the last thing I wanted to recap with, so that we get to understand all these points. So dear students, this marks the end of our lecture for now. And I will summarize and say, thank you so much. And this will be the end, because at 8 to 5:30 I have another class to attend to, and I wanted to recap this lecture of production and operation management. On this topic, the last topic, of course, we say, let me summarize it for your understanding, was the facility planning, and the formulas which I was trying to show, they come, these ones you can read on your own, they come here. We need to know how do we locate, or how do we determine a location of a location of our farm? And the first formula we used was the break-even analysis. And with the break-even analysis, we said we take we use the formula of the total cost equals to fixed cost plus variable cost times the volume, and the lowest figure becomes the area with the lowest figure, area ABC, becomes our alternative. Then the second formula was what we would, this one. This was just a comparison of product volume versus the best price, best side, which is connected to here. Then the second formula was the gravity location problem, which is the one I covered yesterday. And it covers all this, which I've already explained. You need to go through it in your free time. It's just more substitution. These formulas, there's nothing much. You just need to know which figure goes where, then you substitute it. Then the last one is our single facility location problem. So with this, I would say thank you so much.